Every modern enterprise network operates on a rhythm. When things run smoothly, data packets move between servers, endpoints, and cloud services in a continuous pulse. Then the rhythm breaks. A device communicates outside its normal window, or a sudden data spike occurs, and a security alarm fires off in the operations center. Fatigue, not security. An isolated alarm is practically just noise. It tells you something happened, but leaves your analysts blind to the critical details. Who is involved? What specific data moved? Is it a malicious threat or a misconfigured application? Cisco Secure Network Analytics, or SNA, continuously analyzes network behavior to detect these risky deviations. Detection is the starting point. SNA builds out the investigative path, connecting that initial warning directly to the surrounding context. The true value of a security platform lies in how quickly it helps an analyst move from a raw detection to a conclusive, evidence-backed investigation. Let's look at how we investigate one of those isolated alarms. To find what triggered the event, we start with host context. The system ties the alert to specific identities, showing the user, device, and role. From there, we branch out to peer communication, instantly seeing every destination that host interacted with. SNA then links this behavior to associated flows. It takes the alarm and pulls the network communication records tied to that specific moment. These charts show the hard evidence of the network flow. You can see the exact ports, protocols, and the precise volume of data transferred. Using Flow Search, analysts can query this telemetry directly. Instead of manually hunting through unrelated data sets to piece together a timeline, they ask direct questions of the network records. By attaching these flow records directly to the host context, SNA eliminates abstract guesswork and gives security teams a concrete, verifiable timeline of network events. In modern enterprise environments, the vast majority of this network traffic is heavily encrypted. This is necessary to protect data privacy and confidentiality. But this creates a dilemma. While encryption protects privacy, it blinds traditional security inspection tools that rely on reading the contents of a data packet. To restore this lost visibility, SNA uses encrypted traffic analytics, or ETA. ETA avoids the brute force approach of bulk payload decryption. Trying to decrypt everything is resource-intensive, slows down network performance, and violates compliance and privacy limits. Instead of opening the digital envelope, ETA studies the outside of it. It uses advanced telemetry and behavioral indicators to analyze the metadata of the encrypted traffic, creating a unique fingerprint to identify malicious patterns. This approach accurately spots suspicious encrypted activity while strictly respecting practical privacy boundaries. Metadata allows security teams to treat encryption as a behavioral challenge, identifying hidden threats without ever needing to look inside the packet. Now, let's step back from the microscopic network data and look at how this fits into a security analyst's daily workflow. SNA is not designed to be a walled garden. Forcing analysts to isolate their work in a single, disconnected tool slows down incident response. Instead, SNA packages its deep network context and shares it directly with the broader Security Operations Center ecosystem. This evidence flows natively into Splunk, various SIEM and SOAR platforms, Cisco XDR, and Cisco ISE. The result is that precise network evidence becomes instantly available exactly where your analysts are already making their investigation and response decisions. This drastically shortens the time between detecting a potential threat and possessing the hard facts needed to stop it. Because ultimately, Cisco Secure Network Analytics helps teams move from suspicious behavior to evidence they can use.